We're going to continue with our talk on transforming different functions. We looked at different differences multiplying a number or adding and subtracting a number does to quadratic functions. Now, I'm going to try multiplying a quadratic function by a fraction. Let's start. I'm going to call my function p of x, and I'm going to multiply 1 over 2 to the basic format of a quadratic function, x squared. We'll do the same thing as we did before. We'll draw a table of values. We choose a few different values for x. I usually like to go with -2, -1, 0, 1, and 2. Let's plug. -2 plugged instead of x and then squared. -2 squared gives us 4, multiplied by 1 over 2 is 2. -1 squared is 1, multiplied by 1 over 2 is 1 over 2. 0 squared is 0, multiplied by 1 over 2 is still 0. 1 squared is 1, multiplied by 1 over 2 is just 1 over 2. And 2 squared is 4, multiplied by 1 over 2 is 2. Let's see, we have -2 and 2 right here. -1 and 1 over 2, I have to be careful, it's in the middle. 0 and 0, 1 and 1 over 2, and 2 and 2. Okay, let's graph. Now, I can clearly see that the graph that I have here compared to the first graph that I had there is wider. And that's what multiplying a fraction to any function does for us. It makes the graph a bit wider. A whole number would make it narrower, while a fraction, a positive fraction, would make it wider. Now we're going to consider multiplying a negative number to our function. Okay, I'm going to choose a slightly different color, and let's get started. This time I'm going to name the function z of x is equal to, let's try -2 x squared. Exactly the same as before. -2, -1, 0, 1, and 2. Alright, I'm just going to be a bit more careful because I have a negative now. First, plugging -2 instead of x. -2 squared is 4. 4 multiplied by -2 is -8. -1 squared is 1, multiplied by -2 is -2. 0 squared and multiplied by -2 would still be 0. 1 squared is 1, multiplied by -2 is -2. And 2 squared is 4, multiplied by -2 is -8. Interesting. Let's plug in. -2 and -8 is right here. There. -2 and -8. -1 and -2. 0 and 0, 1 and -2, 2 and -8. Something interesting that happened here was that not only did our graph get a bit narrower, as we expected it to do, because we have a whole number multiplied to our x now, but it also shifted downward. It basically was mirrored relative to the x-axis. And that's the impact of negative numbers. I have a -2 multiplied by x squared because it's a whole number. I do expect the graph to get a bit narrower, and because it's a negative, I do expect the graph to flip downward. Now that we have done all of that, let's try another function where we have a negative fraction. You might already be able to guess the impact that's going to have, but let's see it together as well. How about we name this one k of x and -1 over 2 multiplied to x squared now. The same values as before. -2, -1, 0, 1, and 2. Let's start with negative 2. Negative 2 squared is 4, and 4 multiplied by negative 1 over 2 is just negative 2. Negative 1 squared is 1, multiplied by negative 1 over 2 is negative 1 over 2. 0 squared and multiplied to negative 1 over 2 is still 0. 1 squared is 1, multiplied by negative 1 over 2 is negative 1 over 2. And 2 squared is 4, multiplied by negative 1 over 2 is negative 2. Alright, plugging these values now. For negative 2 and negative 2, I'm looking at this part over here. Negative 1 and negative 1 half, it's right here. 0 and 0, 1 and negative 1 half, and 2 and negative 2. We can see that our graph has clearly gotten wider compared to the most basic format or the parent function that we had up here. That's not the only difference. It has gotten wider, but it has also flipped downward. We know being flipped downward is the result of having a negative multiplied to our function. So I'm going to ask us to pay attention to the previous example and the example that we just did. Because both of them have a negative value up front, both of them have flipped relative to the x-axis. When we had negative 2, because 2 is a whole number, we can see that our graph has gotten narrower, and over here, negative 1 over 2, because 1 over 2 is a fraction and is smaller than 1, our graph has gotten a bit wider. That pretty much summarizes all the transformations we're going to have, and we need to know at this stage for different functions that we work with. Now, it doesn't really matter how the function looks like. For example, we can have a function that we're not fully familiar with. For instance, I'm going to say f of x is equal to cube root of x. Even though we might not necessarily know how the graph looks like right now, we should still be able to tell how transformations are going to change it. For instance, what happens if I get the same exact function, but this time I add a 1 outside? Well, let's recall from the examples we went over, we had that case right up here. Having a 1 outside shifted the graph 1 unit up. That's exactly what's going to happen here. Whatever graph we have is going to shift 1 unit up. Let's try taking the same graph but adding a 1 inside right next to the x. Nothing else changes, I'm just adding a 1 inside. Well, let's refer back to the examples we just saw. We had a 1 added right next to the x right here, and we saw that our graph is going to move the opposite direction, 1 unit to the left. And that's exactly the case here as well. Whatever graph that we have is going to move 1 unit to the left. Let's try another example. How about y of x equals, let's recall what other transformations we saw today. Multiplying by a whole positive number. Take a second here to recall the impact multiplying a whole positive number to a function has. I'm going to go to the case we worked on right here. 2 multiplied to x squared made the function a bit narrower. It's going to have the same exact impact right here as well. The same is true for the rest of the transformations we talked about. For example, if I have b of x, 1 over 2 multiplied by x cubed, that's just going to make the graph a bit wider. And the last example that I'll make is c of x, and that is to have a negative number multiplied to our function. Well, if it's a negative and a whole number, it's going to flip and get narrower. If it's a negative and a fraction which is smaller than 1, I mean absolute value is smaller than 1, it's going to flip and it's going to get wider. For example, right here, we're going to have the same exact graph as we had in the parent function, but it's going to be flipped relative to the x-axis and it's going to get narrower. And that's a summary on how transformations basically change our functions. If you have any questions, please let me know.